All right, so yesterday we started talking about the calculations for acids and bases. We calculated pH, and pH, in a simple explanation, is the measure of how blank something is. Let's fill in the blank. What does pH measure of? Acidity. So how acidic something is. So less than 7 is acidic, greater than 7 is basic. So then pOH is a measure of how basic something is. So less than 7, pOH is basic. Greater than 7, pOH is acidic. So it's probably best to focus on pH so we don't get it mixed up. So before we get started today, let's look at the questions from yesterday. So first two were just straightforward single replacement reactions. You should have checked the activity series. If you didn't, you still got them right. All these react. Both zinc and magnesium are reactive enough to replace hydrogen. Yes?
Would you put one on a test where it doesn't react and we still...
That'd be kind of mean, wouldn't it? It's a good idea, though.
No, yeah, I don't think...
So then, for number 2, it tells you that water is the base. So if water is the base, does it give up or accept the proton? It accepts. So what happens when water accepts the proton? What is the product? Hydronium. Okay. So all three of those will have hydronium as a product. There's a different possible answer for C. For C, you could put H2CO3 plus 1 water makes 1 H3O plus HCO3 negative 1. That's also a valid answer. So in this situation, water is my base. What could I label H3O plus as? What is H3O plus? It's a conjugate acid. So it acts as an acid in the reverse reaction. So the acid of the reverse reaction is the conjugate acid. So water is the base, H3O plus is the conjugate acid. Okay? Then it asks you to list out the conjugate base of the following. So those were pretty straightforward. For C, I'm okay with either answer, CO3 negative 2 or HCO3 negative 1. You don't need both. Either one of those is perfectly okay. So then for 4, it tells you that water was the acid. So if water is the acid, what does the water do? It gives away a proton. So what is water after it gives away a proton? The hydroxide. So all of those will have hydroxide as a product. And then hydroxide could be labeled as what? Conjugate base. So in the reverse reaction, hydroxide acts as a base, so it is my conjugate base. So then make a note somewhere. We said that we recognize bases as being metal hydroxides, right? That is one category of bases. However, there's another category of nitrogen-containing bases. So ammonia, NH3, is a base. So we need to recognize that as being a base. So if you want to add that to the front of your notes in the base category, you can. If you take chemistry next year, you'll learn there are a lot of nitrogen-containing bases. But for this class, we'll stick with ammonia. So when ammonia acts as a base, what is the name of the product it produces? Ammonium. Okay, so ammonia acts as a base, then becomes ammonium. Okay. Then, last, it asks you to label acid, base, conjugate base. E and F are straightforward. G is a little bit tricky because they look very similar. Make sure you notice that. HSO4 in the reverse reaction gains a hydrogen to become sulfuric acid, so it is the conjugate base. Then HSO3 gives up its proton to become sulfite, so it is the conjugate acid. Okay? It's just a coincidence the pattern worked out. Okay? Don't try and learn a pattern. I could have flipped those two and flipped those two. It isn't always A plus B gives CB plus CA. Questions about that? Good. So just a summary from yesterday. So hopefully you committed these to memory last night. I know that pH equals the negative log, the concentration of H3O plus. I know that the concentration of H3O plus is equal to 10 to the negative pH. I know that POH equals the negative log of what? Hydroxide concentration. So the concentration of hydroxide is equal to 10 to the negative POH. I also know that pH plus POH equals 14. And I know that the concentration of H3O plus times the concentration of OH minus equals 1.0 times 10 to the negative 14. Under what special circumstance? 25 degrees Celsius. Okay. If it's not 25 degrees Celsius, this is not true, which also makes this untrue. Now, if we're at 26 degrees Celsius, does it technically equal 1.0 times 10 to the negative 14? No, but it's close enough, we're okay. But if we get to 0 or 100, then it's going to be off a little. So for this class, we'll assume we're close enough to 25 these calculations work. Okay? Questions about those? Good, let's use them now. So turn to Worksheet B in your notes. So anytime we're doing these problems moving forward, the first question you need to ask yourself is, do I have an acid or do I have a base? Because acids are going to produce H+, which will make H3O+. Okay, so correlate acids and hydronium. Metal hydroxides are obviously not going to produce H3O+. Metal hydroxides are going to produce what? Hydroxide, not hydronium. Okay? So you can kind of link together base, hydroxide, POH, acid, H3O+, pH. Okay? So number one, calculate the pH of a 7.4 times 10 to the negative 3 molar, what word? Nitric acid solution. So acid or base? Acid. One nitric acid makes how many H3O pluses? 1 or 2 or 3? 1. HNO3 has 1 H. So what is the concentration of H3O plus? Just that number, right? 7.44 times 10 to the negative 3 molar. Then do I have a formula that allows me to calculate pH using the H3O plus concentration? Yes. And what is that formula? pH equals negative log of H3O plus. So type it in. And we're using the log button, not the natural log button. We had that issue earlier today. So before we say the answer, is this an acid or a base? Acid. So should my answer be above or below 7? Below. So we can check ourselves like that. So what did we get? 2.13. We agree? What are my units? I have none. Okay, it's not 2.13 pHs, just 2.13. Okay. And that is a valid answer. It's an acid, it's below 7, so I'm probably correct. Okay? Questions? Good. So number 2, calculate the POH of a 0.15 molar HCl solution. So the concentration of HCl is equivalent to the concentration of what? H3O plus or OH minus? Is HCl an acid or a base? Acid. So what does it produce? H3O plus. So 1 HCl makes 1 H3O plus. So now I have two options. Option 1 is to go from H3O plus concentration to pH to POH. Option 2 is to go from H3O plus concentration to OH minus concentration to POH. Do I have a formula to accomplish all of those steps? Yeah. I can go from that to that by taking the negative log, that to that by using pH plus POH equals 14. I can go from that to that because multiplied together they equal 1.0 times 10 to the negative 14. Then the negative log of hydroxide equals POH. So it doesn't matter which option you choose, 1 or 2. No. I think 1 is easier calculator-wise. But do either one you want to. Okay, so go ahead and plug those numbers in, get a final answer. Should it be a high number or a low number? High. Because it's POH. You got an answer? Does that match what I expect? Mm-hmm. Yeah. So 13.2. The rules are a little bit different for logarithms, so if you just write 13, that's okay. Significant digits aren't super important here because the rules are a little bit different for logs. We can just go with 3 significant digits for now. Yep.
So to convert from pH to POH, you said the negative log again, or?
That's 14 minus pH equals POH. So we'll skip 3. Let's look at 4. What is the difference in 1 and 2 versus 3, or 4, excuse me? Why is 4 different? It's a base. Does a base produce H3O plus? What does it produce? Hydroxide. So what is the hydroxide concentration? 0.25. Because 1 sodium hydroxide makes how many hydroxides? 1. So then I have 2 options, right? I think the easiest option is to first calculate what? POH. How do I go from hydroxide to POH? Yeah, the negative log of hydroxide. Then go from POH to pH. High number or low number? What should I expect? Bless you. High number. pH of a base is going to be high. So what's our answer? So 13-ish, right? 13.4 is what you said? Does that match my expectation? Yeah, so we're probably right. And the last one, 5. What is different about 5 versus 4? Do I still have the base? Yes. Why is the base different though? Yeah, because we'll make 2 hydroxides. So what is the hydroxide concentration here? it double to 0.05 molar. Because 1 calcium hydroxide makes 2 aqueous hydroxides. Okay. Then I would do it, if I were you, the same route. POH, pH. High or low? It's going to be high. And if you look, the concentration of hydroxide is less in 5 than it was in 4, so it should be a lower number, but still on both sides. What do we get?
12.7.
12.7?
How did you get 12.7? Because I got 13.7.
You probably added a 0 when you typed in 0.05. Try it again. So after you get that, go ahead and take about 10 minutes and solve 3 and then 1 through 6. Then we'll pick back up from there. I'm going to pause the video. Number 1 on Worksheet C. Well, first let me show the answers to the virtual. So you can pause it. There are the answers for Worksheet B. Okay. So now, if you look at Worksheet C, let's look at 1 together. It says 0.125 moles of HCl, acid or base? Acid, are dissolved in enough water to make 1.1 liters of solution. What is the molarity, concentration of H3O plus, and pH? So here, I don't give you the number of moles, I give you the number of moles, I don't give you molarity. What is the formula for molarity? Equals moles divided by liters. So I can say molarity equals 0.0125 moles divided by 1.1 liters. So what I would do is type this in the calculator, but then keep it there. So 0.0125 divided by 1.1. So I can write out 0.0114 molar. So that is my molarity. Is that also equal to my concentration of H3O plus? Yes, because 1 hydrochloric acid makes 1 H3O plus. So then I keep this same number and I calculate pH. What is the formula for pH? Negative log of H3O plus. So negative log of my answer. Then I don't have rounding issues. I just keep the same answer and equals, and I get 1.94. So I'll stop and think for a second. Is that logical? Should it be less than 7? Yeah, so I'm in good shape. So what is the only difference in this calculation versus the rest of it? You define the molarity. Okay. What if I give you a number in grams? What are you going to have to do? Convert from grams to moles, then use moles to solve for molarity. Could I ask you to use molarity to solve for number of moles or to solve for volume? Yes. So you kind of see where this is going. So take some time and work on these. We'll probably go over these to start class tomorrow. You still got about 20 minutes left. Okay.